Hello, everyone. We'll wait for a few minutes for everyone to settle in before we start. Yeah. Hello again to our worldwide audience, whether it's morning, afternoon, or evening in your corner of the world. We welcome you to Dynamic Talks by Grid Dynamics. Before we begin, let me take a moment to introduce myself. My name is Rohit, and I spearhead talent, client, and brand marketing for Grid Dynamics in the India region. I'll be your moderator for today's session. Welcome to Dynamic Talks by Grid Dynamics, a platform designed to foster innovation, share knowledge, and connect with the brightest mind in technology globally. We are thrilled to have you here today, and I appreciate your presence as we embark on this journey of learning and discovery. Even if you're not actively job seeking, we hope this discussion spark curiosity about opportunities to join a team driving meaningful technological change. Please allow me to briefly share what Grid Dynamics stands for. We are a NASDAQ listed technology consulting leader trusted by Fortune 1000 companies across finance, retail, and tech industries since 2006. Headquartered in California, we operate globally with over 4,600 engineers in 18 plus countries. As a NASDAQ listed public technology services company, we are at the forefront of big data, data science, machine learning, and AI, scalable omni-channel services, DevOps, and cloud enablement. We are also proud to be a part of S&P Index, S&P 600 Index, a testament to our growth and innovation. Now let's turn to our today's agenda. Please join me in welcoming our esteemed speaker, Anil Kumar Turaga, Senior Data Scientist, Grid Dynamics. Anil is a senior AI engineer with over 3 years of experience, specializing in machine learning, generative AI, and big data engineering. His diverse background spans various industries, including manufacturing, airlines, telecom, e-commerce, and legal services, where he focuses on developing enterprise-level LLM applications and optimizing processes using traditional ML techniques. In the realm of generative AI, Anil has developed multi-agent LLM systems leveraging advanced models like GPT-4o and Claude 3.5 Sonnet for cloud operations. He has implemented retrieval augmented generation, which is what we call RAG, for legal document processing and created multimodal AI applications that integrate LLMs with computer vision models. Anil is skilled in fine-tuning open source LLMs such as Mistral 7B and 3.5 series and has experience in deploying retrieval systems using vector databases like Quadrant and Azure Cosmo DB for domain-specific applications. His contributions to traditional ML and data engineering include developing ML-powered control systems for manufacturing optimization, creating MLOps frameworks for chemical processes, and designing customer data platforms capable of managing millions of profiles. He has extensive experience in building data lakes, warehouses, customer profiles, solutions on cloud platforms like AWS and GCP. An active member of the pre-sales and R&D team at Grid Dynamics, Anil plays a key role in driving innovative solutions, and engaging with clients. He is proficient in a wide variety of technologies, including Python, PyTorch, and various databases and data warehouses. Anil holds a degree in computer science engineering from Mahindra University and is passionate about exploring emerging technologies in the AI landscape. Get ready for an exciting session with Anil as he shares his knowledge and practical insights. Let's give him a warm welcome. Feel free to submit your questions via the Zoom chat during the talk. We'll address them after the presentation. Alternatively, you will get to unmute your microphone to ask them live towards the end of the session. Without any further ado, Anil, the virtual floor is all yours.
Thanks, Rohit. Let me just share my screen. Yeah, let me know if you can see my screen. Is it?
Yes.
All right. Cool. So as you've seen from the title of the dynamic talk, this is about fine-tuning and distillation of LLMs to build all sorts of different applications. So Rohit already did a much flattering introduction of myself, but yes, I'm a data scientist currently at Grid Dynamics. I did a bunch of internships in deep learning before joining full time in a startup. I was mostly into computer vision and explainable AI, and then I've sort of delved into the whole big data engineering and building applications front and back end. So I've did a bunch of everything just to see where I'm good at. Um, so before we sort of start and get into the session, I thought we'd sort of align ourselves in terms of the terms I'm going to use over through the next 1 hour or 45 minutes. I want to sort of break things in three capabilities. So chatbot, workflow, and agent. I'm going to sort of talk more about that. Let's say a chatbot is something that you use in ChatGPT, right? Without any plugins whatsoever, where you just ask a question, you get an answer, and then you sort of build a conversation, a chat as you go on. An important thing to just outline here is that the LLM itself, the model itself is stateless. It doesn't really store your chat per se, right? It doesn't know your history. We pass the history saying that, okay, here is the history of my previous conversation and here is what the new one is. So that's like a simple chatbot. You can put all sorts of context in it and you can get some output back. Workflow, and by the way, this is from Anthropic's blog where they defined like these three different things, is basically a workflow is chaining different LLM calls together. A good example would be, let's say, this meeting, right? After this meeting, let's say you have a transcript and you want to take some action items or whatnot. So initially, you'd want to summarize the specific transcript and then maybe clean it up a little bit if there's any bad words, whatnot, and then finally extract some bullet points of what task to do, right? That's a simple workflow that you could have, and you can have some escapes and whatnot. A little bit of a complex workflow is really more of a map reduce if you worked in any data engineering domain where an LLM will basically span out different tasks, and each task will be taken over by another LLM call, and then all the outputs are fed back into another LLM call, right? Summarization, ranking, whatnot is a use case. One example in the wild is Windsurf. It's if you used VS Code Copilot, it's like similar to that. So when you ask a question in Windsurf, one of the things that they do in RAG is they take your query. They also have the code base as well. They chunk the code base using ASTRAG and whatnot. And what they do is they literally make an LLM call, parallel LLM call per each chunk, and they'll put the query and say that is this chunk relevant to this query, right? They host their own LLMs and they're very optimized. And because it's a huge batched call, all they need to have like is VRAM and whatnot. So the idea here is that to this is essentially a recommendation at scale. So you take your query and you take all the snippets of your different code in your code base and you run them parallelly to identify all the chunks that are important. And then the final LLM will sort of put it together. So that's a more complex and more well expensive workflow. An agent, I think, is what I think everyone is using right now. And an example would be if you go to OpenAI or even Claude, you can ask it some sort of mathematical question. It generally uses program to it write some code to solve that question. So here, the LLM writes some code, but it needs to execute it. So the action is basically, okay, here is some code executed. Your environment would be a simple Python execution, right? Python, just execute that code. And then the output of that program is sent back to the LLM. So if there's an error in the code, the LLM can recover or reflect saying that, okay, maybe syntax error or API issue, let me just try it again. And it can make the action again with the updated code and get the feedback until it thinks that it has achieved the goal. So that's like a simple agent where it keeps on going in this loop until it achieves a specific thing. So three different things. So you have a normal chatbot, you have a workflow, and there are complex versions of that workflow, and then you have an agent. So and if you've been in sort of this generative AI domain, a question would be like, why fine tuning, right? And we've sort of timed fine tuning to be in this specific timeline because there's a way we approach things in Grid. So basically, this industry capability. So let's take generative AI, the whole industry, right? So it more or less really got up in 2023, and it's still going on. The idea is that the capability of the models right now is one thing, and then our own investment in developers is also another thing. So ideally we should invest in engineers or our developers, something that's going to be the next step, right? And to basically talk about that, so in 2023, it was mostly chatbots, right? You have GPT 3.5 Turbo, maybe Instruct version. So it was mostly, you will give it some additional context like RAG, and you will make it answer a user question, right? But most of our investment in that time was building different workflows where uh, it's not a lot of user interaction. As you've seen in workflows, we pass the output of one LLM to the other LLM, and then cut to 2024, workflows got really reliable. Everyone was building workflows. And obviously, Grid, we were also building and productionizing a bunch of workflows. But we were heavily investing in agents. And I'm going to talk about some of the frameworks we used before agents got better. And 2025, now agents are everywhere, right? They're very reliable. And the instruction following of these models also has gotten really good. So we're currently investing in something called long running agents. That's at the model level and also at the application level. And I'm going to sort of brief about what that is. But I've just used agents and long running agents, right? So let me sort of put that together. So we can, and this is my own interpretation. So we can break this term agents, which we've seen where there's an environment, you perform an action, it takes the feedback, and then it can try again. We can break it into like three different pieces. One is the normal agents that are really good. Midterm agents are more or less in the last couple of months we've got it. So a normal agent would run for a couple of minutes. You go to ChatGPT, you'd give it, your assignment, and you ask it to solve it. So you'll add a bunch of code. It will basically go after question, and it'll solve each of them using that code, and it'll put it together, and it'll take 5 minutes or so. Midterm agents have gotten around this time, and ideally by next year, we should get to something called long running agents. And I'm going to talk about each of them. So agents, as I've said, right? Code interpreter is a very good example of a very simple agent. The LLM writes code and executes it and takes the output back, and it does it in a loop to get to the answer. And then DALL-E image generation, it's a tool that ChatGPT has. Before the whole native image generation, there used to be another model where ChatGPT will call that tool, will give a prompt, look at the image, and sort of go in that iteration. Um, so these are the public products, right? These are meant for everyone. But one of the challenges, and I've outlined them here, is when you're building these agents for yourself, let's say you're building code interpreter, like a data analysis agent internally, one of the challenges that you're going to immediately face is the internal data schema. Or the column names being, very bad, et cetera, et cetera. And also the error is not just code failing. There'll be a bunch of semantic errors like not getting any data back when you write some code or stuff like that. So there's obviously a lot of challenges. I've specifically outlined these two challenges because this is not something that the model cannot solve if it gets better, right? Let's say Claude 5 came around 2 months from now. This challenge will still exist. Your internal data sources wouldn't necessarily be in the training data set of the new models or whatnot. So this is something that you cannot simply solve by waiting for the model to get better. So that's your normal agents, and then midterm agents. And I've sort of written taste driven. And once you see the examples, it'll make sense. So easy products would be the recent ones, right? Operator or computer use, where you'll ask it to, okay, book me a table at some restaurant, and it'll go off. It'll click some restaurants and book a table for you. You also have deep research, which I've been loving a lot, where you ask a question, it'll go over and maybe wait for like 100 or 1,000 websites. It'll read all of that and then put together a very long report, like 10 pages. And sometimes you will get like more than 10. So this is something where you would want to implement it yourself, right? You want to implement deep research on your own organizational data. But again, I've outlined the challenges. So if you want to implement computer use on your internal enterprise applications, the UI components in enterprise are generally very complex than for public use, right? Because enterprise applications aren't necessarily meant for user experience per se. They're more meant for utility. You're using that website to get a task done. So you'll provide a lot of options. So it's, the LLM hasn't seen that sort of components very much. So it'll sort of struggle when it's working on your specific websites. At the same time, deep research also struggles if you put your data, because as messy as web data is, generally you link between different web pages, you put hyperlinks to other relevant resources, but I've never personally put any hyperlink in my Word doc linking to relevant information. So our enterprise data is generally very non-linked, it's unstructured, it's, it's meant for a purpose. It's not meant for reading after 5 years, right? And the output itself. So deep research right now, it provides this 10-page report, but you might want a different type of output. So I'm going to cover more of that later. So long running agents, right? So this is what we're hoping that happens next year, and this is based on how, and I'm going to explain how it happens, right? So the possible use case I'm saying is, and this is an example, is like investment, or you can give an agent a portfolio and say that, okay, I need a profit in like what 6 months from now, and this is something that could be possible, right? You can have an agent running for 6 months and get it back. A very hard use case would be asking an agent to write an award-winning novel, right? So first, I'm going to cover the investment thing. So you get an agent and you basically say, okay, here is some money, like here is 100K, and go ahead and invest it wherever you want, and then come back in 6 months, and it should be positive, it should be stable as well, right? So you have multiple metrics. And once the 6 months is done, and basically the important thing with these LLMs is that you need measurable outcomes. So once the 6 months is done, if the task is something where you can measure the success, that is something that can be trained, right? So investment or portfolio is very easy, because let's say it had made some investment in a stock, and then after that the stock sort of took a fall. In hindsight, after 6 months, that's a measurable reward. You can say that, okay, this decision is bad, so let me sort of train it to suppress that, and the overall reward is also possible to see, right? So that's why cases where reward is where you can measure the success, that is something that could be well automated or augmented. Whereas cases like, let's say you want to get like some sort of award-winning novel, right? The problem is, if you train a model on all the previous novel, award-winning, whatever, it's no longer unique, right? Because you're training on previous models. So a reward is very hard to calculate in things like creative writing or stuff like that. If you want to get it at like award-winning, that's a really hard thing to look at. So in terms of, if you're looking into next year, and in terms of job security, look into, well, can you measure your success in like 6 months, and that sort of gives you an answer. So that's sort of three different types of agents, right? And I've outlined like different challenges in all three of them. Agents, it's your own data. Midterm agents, it's mostly with your internal unstructured data, and the outputs and stuff like that. And long learning is about, is it something that you can measure the success of? And this is where we're sort of bringing in fine tuning, right? And I'm going to put it together. So the three things I've outlined is knowledge. It doesn't know your libraries. It doesn't know your internal data structures, output structure. So this is something I've actually personally worked, where you have this, you ask a model to, let's say, mimic a company's brand voice, right? So Grid has a brand voice. If you look at our blogs or anything that Grid has put out publicly, there's a very specific theme that we follow, because there's a good content writing team. So it's very hard to uh, precisely match a style of a big company, because it has a lot of content. You can put few short examples. You can do a lot with agents and prompting, but style alignment is sort of a complex task. And I've written something called CFG here, and it's called context-free grammar. And let me give you like an example, right? So in programming, if you write Python or whatever, there's a very specific structure. You have a function definition, name, arguments, and then return. It's very parsable. You can parse it to get the function name. CFG is something where it's like programming in English, if I can put that. It's like a course in engineering and whatnot, but let's say my sentence should end in, um, well, talk, right? So I can build a CFG where I can ramble whatever I want, but still I can ensure that the last word is talk, right? That's basically me saying that, okay, this is a grammar, and the restriction of this grammar is the last word, right? So it gives you precise control over your output format, where every specific word, every specific character, you can decide which one comes when, right? So that's sort of CFG. And there's a cool library called Guidance. Like I love that framework. It didn't really take off. It's by Microsoft, and it lets you build this context-free grammars and put them to LLM. So instead of structured outputs or tool calling, imagine you can control every word of an LLM output. So that's what it does. And the last one is environment. I think I've sort of covered that, right? In our long running use case, in our investment use case, the environment would be a simulated market. Obviously, you don't want to blow 100K, right? So, or 10K at least. So the environment would be a market that simulates real market, so that the model can play in a sandbox environment. Right? So that's sort of functioning. And to put that environment back into your own processes, right? Every company has their unique processes. Like let's say promotion is internal promotion, right? Every company has its own thing. You can make that an environment, right? So do something in the next 3 months and your reward would be promotion, right? So if you look at how Google does it, they have very specific, they have like a huge check boxes of checklist of what you should do to get a promotion, right? That's a thing that where you can calculate the reward. So that's the environment. So these three things might not be solved as the models get better. So the models will get better at instruction following, they'll get good at programming and lots of things. But these three things are sort of not, one, they're not available as public data. And two, the people who are building the model should also care more about it, right? They don't necessarily care about what our companies, our personal companies' brand voice is, so they won't train for that. So it's either that you don't have the data for the LLMs to get better at that task, and two is they don't really care about it as much to solve it, right? So these two things sort of fall into domain. So before I talk about fine tuning and LoRa's and AWQ, whatever, I want to sort of talk about how LLMs are trained. It'll be simple. Once you sort of see the whole picture, it'll be like quite simple. So the first step is pre-training. You take these LLMs and you put them through web data, right? And a lot of people think that pre-training is just dump everything, but in the whole training pipeline, there's this thing called curriculum learning. So it's the order of training, right? So let's say it's very similar to how we train, right? So if I want to learn data science, I wouldn't start by looking at the architecture of transformers, right? I would probably look at calculus. So the order of learning is very important. And even with LLMs, you sort of put the easier ones to learn first, and then the complex stuff comes later. And we're going to reuse that concept in fine tuning later on as well. So pre-training is trillions of tokens, and tokens could be words. You train it to predict the next word. And then comes mid-training. So this is something that, believe it or not, OpenAI sort of made it popular. I would say they've created a mid-training division like in 2 years ago. And the thing here is again very similar to how do you make it PhD level, right? So once your pre-training is done, mid-training is where you take very domain-specific data sets and you again ask it to predict the next words, right? And you again order it very specifically. And mid-training is sort of crazy where you get a pre-trained model, which is one model. You actually take versions of that model and you train it on different orders of data and you merge them back because you don't really know what order to put them together, right? Uh, I mean, I don't know if chemistry is important to learn calculus, but I don't know, it might be. So mid-training is where it's much more aligned towards getting it better at specific tasks like math or science or programming or chemistry, biology, medicine. So it's very high quality data. And the reason why I'm stressing on this is uh, so you've seen this knowledge cutoff, right? And currently the knowledge cutoff is what, March 2025 of Claude. So how they do it is they have this pre-trained model. Mid-training is where they add this new information of new news or new library versions. That's where, because mid-training is all about this very, very precise and really important complex topics. Mid-training is where you add new information. And then once these two are done, you get your nice little base model. And base model, you can just think of it as autocomplete. You write a sentence, it'll just predict the next word. You cannot ask it things because if you ask something, it'll just complete the question. It won't answer anything, right? And now you take this base model and you put it through post-training. Post-training is like everyone does their own thing, but there's like a popular, at least open source version that has come out, which is SFT. SFT is like your actual chat, right? Like, hi, hi, how are you? And it'll answer, I'm good, how are you? So this is where you actually have chats and you train the model to sort of learn how to chat, and that's how it does that. And it's like millions, and you can see the scale of data is coming down, right? It started with trillions because it has to understand English and all that concepts. And then you made it really good at very specific topics. And now it has all this really good information. And now post-training is all about making it more aligned towards how I want it to respond. So SFT is literally training it on chat. And then pre-FT, which is preference fine-tuning, where I want to kill myself, and it'll probably say, well, if you just complete it after SFT, it might say, yeah, go ahead, I don't really care. But preference fine tuning is more about, don't do that, get help, stuff like that. So it's like DPO. So I can have DPO is basically it's like a preference. So I've given you two examples, right? One is yeah, go ahead, kill yourself, I don't care. And then you have the other one which is more, oh, don't do that, get help. And you take both of this and you basically it's like carrot and stick. This will be the model's carrot and this is your stick. And you'll basically train it to not do something and also do something. So it'll be more aligned towards being good, right? Don't do bad stuff is sort of the mantra. And then once it's done, and this RLVR is it spans a lot of things. One is RLHF, which is reinforcement learning with human feedback, which you can go to LM Arena and whatever, and you've seen in ChatGPT, right? You ask a question, and you give you two things, and you can select that. So it's part of DPO, and RL is more about how do I put it? You ask it a question, let's say a math question, you give it some sort of equation or your assignment and you ask it to solve something. Uh, so the way RL works is you will ask the model, you will basically make 8 copies of the model, let's say. You wouldn't actually make copies, but you will make the model generate 8 or 12 or whatever number of responses. And it's the same carrot and stick with DPO, where in DPO you actually need the get help and the sentence itself, right? Let's say you don't have the sentence. RLVR is about reinforcement learning with verifiable rewards, where I know the correct answer, not in like sentence or answer. I know like for this math equation, I know this is the answer. So you make the model basically try like 8 times in parallel, and it's the same carrot and stick applied across 8 samples. So the one that gets it correct, the actual keyword of the answer, you give it a good carrot, and then all the other ones will get stick. So RLVR is a much broader, and I'm going to cover it in detail as well. And then the one that you get is the instruct model, which is pretty. Which is what we all use to chat and code and whatnot. So that's like the overall training pipeline. Uh, Not gonna cover this too heavily. This is again a very oversimplified version, and if you're like a data science, you'll probably be cringing. There's no residual layers, there's no normalization layers, but it's sort of simple. You talk to LLMs in like image and text, right? You can give both inputs. It takes that image is sort of encoded into a dimension. Text is also embedded into a dimension, and both are sort of put together. So when the LLM sees it, it sees some text and it literally sees an interpretation of an image and sees the other text. So it's like one long input for the LM at the end. And multi-head attention, where everything is compared with everything else. MLP is figuring out what to get there, and your LM head is what predicts, right? So the reason why I put this is I think I put it here. In fine tuning, and these are big models, right? Big boy models. You have what 400 billion is one of the biggest open source models we have available right now. You can't you can't fine tune the whole model. So you have to pick and choose what to train. And it's sort of straightforward and not so straightforward on picking which one to fine tune when we're actually making that decision. And sort of talk about that as well. So as I mentioned, right, these big boy models, these are very hard to fine tune all by themselves, but I'm going to talk about that as well. So how do I put it? So you have the model in some precision, right? It's taking some, it's represented, each weight is represented, each neuron is represented in some math precision. So it's like how much data you put to save that. And there's LoRa, where instead of training the whole model, you'll sort of train an addition to it, right? So LoRa, you can think about it as a much lower consumption of training a model, right? Think about it as you can train it on smaller GPUs in faster time at some hit of performance because you're not training the whole model. And then QLoRa is basically, it's much more constrained. It's like the model is compressed into a smaller representation. You compress the model, but the updates still happen at the original layer, right? Because the model was trained at some precision, some bits, and then now you compress the model, but the updates to it still happen in when it was trained, obviously. So that's like QLoRa. Can read more about it. It's like some it's not that hard math, but that's that. So standard is you training the big model. It takes a lot of VRAM. It takes a lot of time as well because you have to train each layer. LoRa is where you train like an addition to the actual model, so that you're only training a small number of parameters, right? And this is all frozen, so it gets sort of faster and it takes less memory. QLoRa is where you like compress the model itself, so you can save it. You can train bigger models on smaller GPUs and probably at like faster memory as well. So this is in terms of the model training. But in the model itself, as I've covered, we won't train all pieces of it. We're going to pick and choose which ones to train it based on the use case that I'm going to cover. So that's sort of that. And yeah, types of fine tuning. So this is obviously a reason why I've given you the training and the model architecture. So there's four types of fine tuning. One is continued pre-training, supervised fine tuning, DPO, GRPO, sounds something. I'm going to sort of put it back into what we've covered, right? So knowledge is where it doesn't know about your internal library. In Grid, we have a bunch of internal libraries, but RLMs doesn't really know how to, write code in that. And continued pre-training is positioned as a thing around that area where you can teach it new stuff. And then in terms of output format and all that, right? And you should know that continued pre-training, as we've covered, it's on the base model. Supervised fine-tuning and DPO is your preferences, like, kill yourself versus the other one. Is more at the chat level, right? You're moving into the chat models. So you can ask it to, you can fine tune it to be much more aligned towards a style. You can fine tune it much more into your CFG to generate like the last word should be talk. And then the GRPO itself, where once you have this nice little instruct model, you can now uh, well, fine tune it to either reason or sort of get to a specific answer, right? Where GRPO is really good, where you can have like verification is easy, but creating the answer is tough. So an example would be, and this is not like sort of there, but um, so let's say you have a 3D printer, right? Or like industrial 3D printer, not one at like our lab or something. So you want, like what you want, the constraints of the 3D printer itself. So, and you ask the LLM to sort of generate a screw wrench or whatever, right? So the thing is, the LLM can generate the screw wrench or whatever. The verification is easy, right? You can verify that if the model is printable in your 3D printer or not. So the verification is easy, but the design, the answer, right, which is the wrench itself, that is harder. So generating the answer is harder, but verifying if it actually is, it can be printed or not is much easier. So your GRPO, your RL is really good, where verification is much more easier or approachable or possible rather than actually creating the solution, right? Because if you can create the solution, you're back to DPO or you're back to supervised fine tuning, right? So that sort of everything comes into picture. You don't need to like know all of this, like just an intuition of different versions and how they map back is like more than enough. Um, so I thought I'd cover this with little examples. Why we choose a specific fine tuning, and I'm going to use different examples. So for knowledge, I'm going to use languages. So believe it or not, I mean, you probably have noticed like LLMs are good at English, but other languages they sort of struggle. And if you're building a product for Europe or something like India, it's sort of hard because you need to converse in the native language and in the accents and in the specific dialect that they use, right? So for example, I'm from South India. We have Telugu. The Telugu that ChatGPT or whatever uses is extremely formal than what we actually use. We also use something called transliteration, where we speak, when we're writing Telugu, we don't write in the actual native script. We actually use English letters to represent it, right? So ChatGPT and all the frontier models are not good at it because, again, it's something that the model, the training people, they don't really care about, right? They don't care about using English letters to write in Telugu when they're training the model, right? So language quality or stuff like that. So this is where I want to teach it a new language. And then multi-edit prediction. So if you used Copilot or Cursor or Windsurf, there's this cool thing called multi-edit predictions, where you're typing something and then it'll immediately see, okay, this is the completion, and you'll click tab. And then immediately it'll jump to the top saying that, okay, import this thing, and you'll go there, tab, and then tab again. So it's the tab model. So how are these multi-edits, like how does it work, right? It sounds magical. It's like working across like my 1,000-line program, and it's very specific. So I'm going to talk about how you can build that. It's surprisingly easy. And then content writing. Content writing, as I've said, right? I was talking about how RL is something where you can compute the reward of, and I'm saying content writing. So it's this content writing example that I'm going to use. The model came yesterday, so I had a different example, but this model literally got open source yesterday, and it was a really interesting approach. So I'm going to cover that as well. Just going to look at the time. We're fine. Um, So yeah, so I'm gonna sort of talk about in different phases. So just to sort of give things, so I'm gonna take three different use cases. I'm going to cover them parallelly as we sort of take them through the fine-tuning approach. One is teaching the LLM to be good at a specific language. And I'm going to talk about the challenges and the limitations as well. And then the tab predictions where you make one edit and one file and it'll automatically predict changes at 5, 6 places. And then the third one is content writing, making it good at some style. Generally SFT has been used for content, but we're gonna show an example of GRPO, which is pretty cool. So we're going to cover like what type of fine tuning to use. First is obviously use case discovery, right? And I hopefully have given you enough information to understand how to identify use case, right? The whole knowledge, output, and environment. You can think of any challenge that you're facing when you're building agents. So just in terms of your daily life and see if it falls into any of those three buckets, and you can basically fine tune your way into it. And it's far more approachable than anything in ML or DS. That's sort of how you can think about use case discovery. So once you have a use case discovered, it's sort of important to decide which type of fine tuning to go for. And we've just covered that, right? Continued SFT, DPO, GRPO. And then quantity of data, this sometimes is in your hand. Most of the time it's not in your hand. You can't invest in like human annotators to get the data for you, right? So that's that. And then the collection of the data itself, once you decide how much you want, you have to collect it. You have to transform it so that it's more aligned towards the model itself. And the fine tuning itself, and how do we evaluate it, right? And evaluation is I haven't seen a lot of evaluations in the wild for agents per se. We're going to give it a shot, but if you're sort of new to generative AI and if you think you want to make a mark, and I think this has been repeated by pretty much everyone I know, evaluation is a very good place to look at because even now n-grams are probably the most used evaluations there is. Doesn't matter if it's a workflow, doesn't matter if it's a chatbot, doesn't matter if it's an agent, we are still limited to looking at n-grams or direct matches. So evaluation is a very nice field that that can take more people in. So types of fine tuning. So for language quality, because I'm going to teach it a new thing, it falls under continued pre-training. And if you remember, and I'm going to go back a little bit quick, if I'm doing continued pre-training, it's going to fall on the base model. And I've said that base models are nothing but autocomplete, which means that now I have to do my own, DIY version of post training. I have to instruct fine tune it, right? Which is like SFT or whatnot. So I have to teach it to respond to something instead of just continuing my own question. So so I've given you the answer right away, right? Continued pre-training is an incredibly hard thing to do at scale, at least. And generally, you're better off going with RAG. If it's like translation, there's a lot of good translation models and et cetera, et cetera. Because continued pre-training runs on a base model, and there's not a lot of use cases that you can do with base models or products you can build. So you have to do your own instruction fine-tuning. The multi-edit predictions, we're going to do SFT, obviously, and then we're going to do DPO as well. And then for content writing, it's obviously GRPO. So all these three different use cases, they're all open source. And I think you've probably seen it in the invite. I'm going to share all the resources that I've looked at to put this together so that all the code, all the data sets, pretty much all of them are open source. We might even provide like one of our own internal R&D models as well. We'll see how that goes. But yeah. So types of fine tuning. We've decided what fine tuning we want to do. And then we have to decide type of model. And I think I've covered it. Language quality, it's a base model. But wait a second, I just said, SFT and instruct and blah, blah, blah. And now I'm showing base model. So this is and given the answer again, but this is a cool sort of thing is there's a different versions of models. So if you looked at open source models, especially, you have base, you have instruct, and there are two variants of models that are put out as well. Let's take Quen. So Quen 2.5 have Quen 2.5 VL base, Quen 2.5 VL instruct, Quen 2.5 coder base, Quen 2.5 coder instruct, and then math, Quen math, and then Quen math instruct. So the reason for this specific task we're using base, and this is fairly only because it's a coding problem. in programming, when they're pre-training these models, they do something called fill in the middle. And it's better to show it as an example. So let's say I take this, right? And I have 2, 3, 4, 5, 6, 7, 8. One naive way of doing pre-training is basically training, okay, you have first line, predict the second line, or predict the first word in the second line and third line, fourth line. One of the things that, done in the pre-training is basically they take this out. They basically say fill in the middle prefix and then fill in the middle suffix, and they make it predict the, well, in the middle, which is 4, 5, 6, right? So this is done at a pre-training level or more at mid-training level. So this is very specific to coding, and that's why they release a specific coding. They have other BR as well, but this is something that almost all uh, pro, uh, coding models have, where fill in the middle is sort of baked into the pre-training itself. And instruction fine-tuning won't have a lot of fill in the middle, right? Because when you go to ChatGPT and ask for a code, ideally you would ask it to rewrite the whole script, right? You don't want it to say, oh, here, add like 3 lines. Remember, like 2 years ago, it used to say, add this line here, add this line here, and we'd just say, that's not my job, that's your job. Give me the whole code. So this functionality is suppressed a little bit in like larger models when it goes to instruct fine tune. So for fill in the middle problems and in programming tasks, it's much better to go with base. So that's sort of how it works. And content writing, we're going to use an instruct model, right? Because you're asking it a question, you want it to respond in a very specific format. So that's the type of the model. Good. Quantity of data. And obviously, because you're thinking about continued pre-training, you better have a good amount of data set. You need a lot of data points. And then for multi-edit predictions, you actually don't need as many, especially if it's something that fits into the distribution of the model. And this is, again, an important consideration to have. If you're thinking about fine-tuning for something, make sure that there's some version of that problem in the training data set of the model. It's not that hard to find it. You can go to Hugging Face and there's so many data sets that are open source. If you can find a data set that's a little bit close to your problem, it's fairly good to think that, okay, fine tuning will work, because auto distribution is sort of hard to fine tune for, especially, I've tried it with my own native language, and fine tuning fails miserably because there's just not enough data in the training data set, the transliteration problem I've mentioned. Cool. So multi-edit, 800 samples, 150 pairs. So all these three others said, there are done by others in open source, and I'm just going to talk about that. Content writing, and this is where it sort of gets cool. You don't need question and answers, right? In multi-edit predictions, you need a chat data set where you ask a question and you get a response. And in language as well, in instruction, you ask it a question, you get a response back. In RL, you don't need the answer. You just need the questions and a way to verify that. And I'm going to reveal it a little bit later, but you need the target style content. So if I'm trying to do it for, let's say, there's a publication, like older publications, right? 19th century publications, and you want the model to answer just in that format. Obviously, you can prompt the model to do it, but it won't be authentic, right? Because it's just not aligned towards that. So if I want a model to respond in 19th century Irish, whatever, and that's sort of the model I'm covering right now. So there's an Irish journal, and you want the model to respond in the style of that journal writing, so the words and everything that are being used. So you only need two things. You need normal questions in English, doesn't have to be anything, pick any chat data set, and the target style content. Cool. And the data collection. So for language quality, you're going to take a Wikipedia. Wikipedia has like pretty much a bunch of languages covered, right? You can get all articles in all different languages. And you need a conversation data set for instruction fine tuning in the same language as well, so that it understands to respond. Um, and in multi-edit predictions, we're going to use pure models. So in multi-edit predictions, think of that it's much more of a distillation in tab models, right? You don't expect it to write complex answers. It's mostly about latency. It has to quickly, if I add a variable, it should say, okay, declare the variable at the top. So that's more in terms of, it's not in terms of the capability per se, it's more in terms of distilling the incredible knowledge of these larger models so that it does the task much more quickly. And then you do DPO as well. DPO here, you have to use real users. You can use an LLM as well, like the whole multi-edit, but you can build your own tab model with just Claude, and it could like it could get close to Cursor's quality, not their productionization, but you can get the quality just by using Claude. So for creating the dataset, the chat dataset, and the DPO preferences, you can get away with Claude. And for content writing, as I mentioned, if I wanted to generate in 19th century, whatever, one way would be to me taking the journals, putting it into Claude and saying, oh, generate question and answers for this, and then it can generate. But one way to do it is you just get some questions randomly, any questions about anything, facts or whatever. And then now that you've gotten the style data, you can train a classification model, right? And as I've mentioned in RLVR, the verifiable reward, right? You just have to verify the response. You don't have to create the response yourself. So if I get a model, I ask it a question, I probably prompt it to say, generate in this specific style, it'll generate something. All I have to do is verify that. And I can just have a classification model to say that if it falls in that style or not, right? So you don't need answers anymore. You can have 100,000 questions about whatever you want, and you can basically give the carrot and stick to get the model aligned towards the style you want. So you don't have to even give it examples really, and I'm going to show that as well. So data collection, I've jumped right off to multi-edit predictions. This is going to be a little bit complex. So this is how it actually works. So this is how Cursor, this is for Z actually. I don't know if you know Z. So Z is an open source editor, and they have trained their own thing, and they've open sourced this methodology as well. And it's their own data set. It's called Zeta. You should look it up. It's a cool model, really. The performance is also very good. So let's take about user edit. So how does it work? As I've said, you type something. So let's say the user is somewhere around here. So this is a diff in Git. So you said that name equal to name, and you edited name equal to name dot capitalize. So that is what you have edited. And now you want predictions after this task, right? And you create something called the excerpt, right? The excerpt is you tell the model in which region it can edit things. So ideally, you don't need it. You can put the whole file and let it do whatever it wants. But you can give it like an editable region. Whatever the user is seeing in the on the screen, you can put that as part of the editable region and say, and you can also see that the user cursor, right? So because I've just added capitalize, I'm gonna put my cursor here. So based on this information, I'm asking the model to basically predict all the next ones, right? And you can see, oh, the name, he's capitalizing it. So probably email and phone and whatever also has to be capitalized, right? So that's the prediction. So when your copilot or whatever are doing multi-edit predictions, it's basically they're looking at one specific change. They're putting, oh, here is the cursor. So make changes around the cursor because that's how we do programming, right? We edit around the cursor. And the model will literally predict a chunk of text on where it wants to do it. So that's sort of how it works. There's also more complex stuff. Like you can go to my blog, I'll put it in terms of the link down, where there's a much more, all the complications that come out of this. It's called character prefix conditioning. What if capitalize is not fully there? It's a cool blog. You can read about it. You don't have to know anything. You can just, it's a more of a data structure problem than anything else. But that's that. So this data set, as you can think, you can create with Claude. You can prompt it to say, I need a diff, create a synthetic script about some sort of thing where the user has edited something, and then generate a response. So you take this and you ask it to generate this, and this you can just make it up on your own. Right? This is more about your own constraints. And you can create this data set, and that will be your core SFT data set for your multi-edit. Now going to content writing, which is what I like. So you want to classify something, right? And I mentioned that you need to get data to classify. All you need is the style data, right? But how do you classify something? You need like, two things to classify. Like you need a positive and negative. So what you can do is you can take the original style, the Irish, what at least he did was he took the original style text, he chunked it into like 50 to 150 words, and he put it in an LLM and asked it to modernize it. So it's a whole synthetic data set. He took the actual old style 19th century text, chunked it, and asked it to be modernized, and now you have a labeled data set. for classification. At this point, you just train a classification model, and if it's get to good enough accuracy, you have a reward for your RL. So that's the data collection. So we've covered like those three parts, and then we moved on to transformation, right? So we've collected three different data sets. For language, it was just Wikipedia and some chat data set. For multi-edit, we've used LLMs to generate a bunch of user changes and predictions. And for content rating, we probably we can train the classification after that part, and we need a prompt. So let's go back to our language quality. For language quality, you need to, as I mentioned, it's a continued pre-training, right? So the left one is continued pre-training. This is from Unsloth example. So continued pre-training, as I've said, it's like a whole text, right? It's like a document. So you can structure the document, and this is for Korean. So if you want to make a model good at Korean, this is how you do it. So this is the actual prompt. This is the English version of it. So you say Wikipedia article, and you put the title of that article and the article content itself. And this will be your text to continue the pre-training of whatever LLM you choose. And once this is done, you will move on to instruction fine-tuning. Um, so obviously, this is not how chat datasets look. They have a user and assistant and all that, and I'm going to show that as well. But this is like a mid thing that happens. So if you remember, GPT 3.5 actually had an instruct model as well, where it's about instruction and response. And the instruction is where you put your user message, and then the response is where you make the model predict. So you're gonna have that as well, right? And the same thing. So this is the example in English, but this is the actual prompt. Cool. Next one is multi-edit. So now you need to prompt the model on how to do it, right? You have to put this data together. So you put a template like a Jinja template or whatever. You say that you're a code completion agent. Your task is to look at user edits and then the excerpt as well, and rewrite the excerpt in the middle of what is allowed to suggest different edits, right? And you provide these two things. And you've seen and if you remember, I've just said that is the type of fine tuning, right? Which is base model. So for language and multi-edit, they're both base models. On language, we're doing continued pre-training and instruction fine-tuning. For multi-edit, we're simply going to be doing instruction fine-tuning because it already knows fill in the middle, right? So going back to this thing, so it's the same as the one you've seen. You give an instruction, you give whatever you want, and the response is where the LLM will respond. Cool. And then for content rating. So as I've said, instruction fine-tuning is not how your actual chat models look. So when you're sending a user message, it's sort of turned into this thing. So your system message is where you write your instructions. You here, so these are not the classification model. So classification model is done. We've basically trained it to do different styles. Um, so we have that. Now we want to train an actual LLM to output in that style. And this is an important thing. When you're fine tuning, it's incredibly important that the response of the LLM could be completely derived from from your instructions and the user message, right? Uh, so one of the most common pitfalls I see is if you're building an agent, if you're building a workflow, you put a bunch of context in the bunch of content in the context and make it do an answer. But when people get to fine tuning, they remove everything. They remove the examples. They just put like, oh, do this, because the assumption was that, oh, it'll train, right? So it'll automatically understand that it has to respond like that. But all you're doing in that case by not giving enough context is you're basically encouraging the LLM to hallucinate, right? From its perspective, for a single data point, it has to make up something. It is being given carrot or stick for something that's it cannot possibly derive. So if you have an agent where you have the best practice would be if you build an agent with 10 examples in the prompt and you're fine tuning, have at least one or two examples so that it can still derive it in some way or the other. So that's what they did here. You are a learned assistant whose every utterance is penned in, and they've styled it in the same version. The Irish Penny Journal, which is what they're training for, be descriptive, poetic, and rich in historical color. So the text itself is in that format, and they've specifically mentioned what style they want. So that you're giving enough context to the LLM still, so that it sort of works. And then the question is simple, right? It's just what is the capital of France? It has probably nothing to do with the journal itself. So the questions can be anything. And yeah, we can sort of move on from this. Cool. Model selection. So this is it seems like it's a simple task, and I haven't seen a lot of literature as well where they help you about model choice. But boy, oh boy, in my experiments, the model choice surprisingly has a lot of impact. Um, so for language quality, right? And again, this goes back to my previous foot gun, right? Where you have to ensure that if you're training for something, a version of that data already exists in the training set of that model. So Llama, obviously, because they have Instagram, they have Facebook, they train on a lot of multi-language data sets. So when it's about different languages in the open source realm, Llama is like a nice one to work on. For multi-edit, Qwen Coder, the coder version of the model is good. So right now, so if you again follow through in 2023, Mistral was the most popular open source model. Mistral is a French-based startup, and they put a bunch of really good open source models in 2023. 2024, it was all Llama. Meta like sort of took over the whole thing. 2025, it's sort of um, for larger models, larger reasoning models, DeepSeek, as it is popular, is good. For smaller models, anything till 32 billion or 70 billion, 72 billion, Qwen has no competition. Qwen 2.5 and even 3, the reasoning models that we've gotten, especially for fine tuning, it's a very good model because if you look at the literature in the last couple of days, there's a paper where they take Qwen 3 or whatever. Uh, they take this RL, right? I've told you about this whole reward model. They give random rewards to the Quen model, and it still outperforms. It still gets better performance. And there's a lot of assumptions as to Quen might probably have a augmented version of the test data sets in pre-training, whatever it might be. But for fine-tuning Quen models till 72B, and that's where most of our budgets are. Quen models are really good. At least for proof of concept, we can try that and then go for more permissive models as well. So Quen. And then for content writing, we have two models, right? One is the actual LM that we're going to fine tune, and the author there has chosen small LM. So small LM is done by Hugging Face team. So Hugging Face also another Hugging Face team itself actually has a lot of open models and open data sets published. And small LM is like this tiny model. It's a very good model. It does good tool calling. It does good instruction following. So the author has chosen that. And for classification, they've chosen BERT, right? Because it's still natural language text that you're classifying against. So they've chosen BERT for that task. And then fine-tuning parameters, going a little bit fast, but sure. Um, so this goes back to why I've covered the architecture of the model. You don't have to know this. A realistic way of approaching this is use the ones that are suggested by the library you're using, right? You can use Torch Tune, you can use Unsloth, you can use TRL, which is Hugging Face's version of fine tuning. So there's like lots of fine tuning offerings, and they have a lot of guides on using the models. Most of the time, you can and you should get away with the default hyperparameters they have, and the reason is simple. And this is something that Unsloth does. Whenever they get a new model, they have a bunch of internal data sets where they do the hyperparameter search on the data sets and and basically they choose the ones that are performing well. So in terms of rank, in terms of learning rate, that's how they arrive to that point. Even if you go to OpenAI fine-tuning offering, they wouldn't really let you define the rank, right? Because based on their internal, and this gets very specific to each of their model, each type of model. So most of the time, stick with the hyperparameters that are suggested. And I've only given you, ideally, there's like what 30 different hyperparameters you can work on, but I've only selected a couple of them. These are the ones that you probably can change to get good performance. If not, that's that, I guess. So I'm just going to quickly cover the actual ones. So language quality, because it's a huge data set and it's going to take forever if we train it on a large model. And this being an example, they've used QLoRa. And as I mentioned, QLoRa is where you compress the model but still make the updates in full precision. The rank is 16, and 16 is like the go-to for Unsloth, and that's where both of these authors has used Unsloth. This is different. Epoch is one, and this is again important. You should again stick with one epoch as long as you can, unless you have a very small data set and you're sure that the generalizability is higher in your data sets, then you bump to epoch 2. But epoch 3, like, and let me give you like a more thumb rule is, if you're going for generalization in terms of style or output, epoch 1 or 2 is fine. If you're going for a fact-based thing, right, where it has to, you should make sure that the LLM has to, a good example would be refusals, right? If you want the LLM to refuse for something, that's something that has to be done. That is where you can have more epochs, right? So that you can make it refuse. So more epochs will make it sort of overfit, but also like learn it, like by heart it. So you don't want that as much. Learning rate, I think it's, everyone knows it, right? You have too much learning rate, it'll just overshoot and it might not converge faster. Batch size is, so batch size, you can try with different things. We're mostly constrained by the GPU, right? So you put more batches, it'll sort of lead to an increase in VRAM. So, based on your GPU, and batch size also the same thing, right? Batch size actually goes with your code quality. If you think that your code quality is really good, you can sort of have a lesser batch size so that it gets that carrot or stick for that specific data point. But if you think that it's sort of, you don't care about learning that specific data point, but sort of an emergent behavior as in multi-edit predictions, you can have a larger batch size as well. So batch size is good in terms of your data quality and also what exactly are you trying to get out of it. Rank is, I wouldn't like want you to touch it, but it's like up to you. So rank is like uh, how many parameters you're updating at a time. And the more you're updating, the more the model will basically take steps. And epoch I've already covered. Epochs is, if you want facts, put more epochs. If you want sort of emergent behavior, one epoch should be more than enough. And for content writing, the author did full precision. And remember, it's a 1 billion model, and the GPU they used is 48 GB VRAM. So at full precision, that's how it is. In contrast, the QLoRa version, where it's a 7 billion model, but you can train it on, what was it, 16 GB. It won't even take 16 GB. I think 11 GB or something would be its consumption. So that's how QLoRa. So you're training 7 times as big or 3 times as big of a model, but QLoRa will make sure that you don't need as much VRAM, so you can get away with that. So here are the learning rates and batch size. So number of generations. So I might shift to GRPO1 again. So as I mentioned, right, you take a model, and then you give it a question. What you do is, and you probably can test it, right? LLMs generally generate a new response every time you ask the same question. So you can go to ChatGPT and create a new chat every time and just say hi, and it'll probably give you like 3 different versions out of 8. So what you do is you get like different answers. So GRPO is sort of very simple. You make it generate a bunch of answers, and because I've said all we can do is verification, right? So let's put a control thing here. So you verify and you give some sort of reward, right? It's like 0 or 1. If it's good, you give 1. If it's bad, you give 0 or anything in between to all these 3. And then this turns into a DPO problem, right? Because you now have reward for each point. So all 3 are sort of trained. So this is basically GRPO in a nutshell. There's more going on behind the scenes, but this is what it is. And the number of generations they've used is 12. So for every question, you are getting that model to generate 12 versions. You are basically classifying all the output text between like the score, right? The classification will have a classification score, and that would be directly gone into the reward, right? It's a 0, 1. It's a cute thing. And evaluation, the final good one. So as I mentioned, right, ngrams is sort of go-to for continued pre-training, and you can do sentence similarity as well uh, on your fine-tuned data set, where you ask a question in Korean and you will get an answer in Korean. And because it's a chat data set, you have actual labels as well. So you can just compare how many keywords are there, what's the general sentence similarity between those. In multi-edit predictions, it's a subjective thing, right? You can define a variable in 100 ways. So the one that Zeta has used is mostly LLM as a judge, and they use like a score from 0 to 5, and like assertions is you write tests, right? Like assert, it has to do something. So the LLM, the assertions are more natural language, and then it basically the LLM will be a judge. They just use Claude to judge the model things. So I'm gonna put it back there. So in multi-area predictions, you've trained, you've SFT, you instruction fine-tuned the model. And what you can do is you can take this LLM as a judge and you do the same thing like GRPO. You get the model, you give it a question, you'll generate two answers. And here the verification will be Claude. And this again turns into a DPO, right? Oh God, sorry. This turns into that. So for DPO, you can create your own DPO dataset just by using Claude. So that's that. They've used real users, but you can just do that. Content writing, it's the classification model score, right? And it's not just like, and obviously for evaluation, they've looked at the, how the mean is going and also the overall standard deviation. So for a specific eval set, the overall score should be on the higher end, was their sort of thing. And finally to deployment. And I've only used two. There are other deployment methods as well, but these are like really good enough to do. Olama. So Olama is based on a thing called Llama CPP. And it's a very good wrapper. It's a very nice developer friendly wrapper. And it's like Olama run and it'll serve that LLM for you. And both these versions you can use OpenAI. So you've used OpenAI SDK or LangChain or whatever. It will be directly compatible with tool calling, with vision, everything. So Olama is like really developer friendly, but if you are going for a more production deployment, VLLM is a really good open source one as well. They have like custom kernels and everything. They have a plugin called LoRa Resolve. So the reason I'm talking about this plugin is we are training adapters, right? If you go for LoRa, if you're going for QLoRa, we are training adapters which are just updates to a model. It's not a whole model. So in an ideal world, you take a Qwen 2.5 model, you have multiple fine tunes working, you get like 4 or 5 adapters, but you can serve all 4 different applications with just one deployment of the model, right? So VLLM will basically have the model, and whenever it gets a request for a specific use case or an adapter, it can get that adapter onboarded to the LLM and then serve that request. A little bit of latency in onboarding and on that, but you can basically serve 4 applications with just one deployment of the same model because it's all just adapters that you're using. So, and yeah, OpenAI compatibility is that. So yeah, I'll probably speed run through the whole thing, but if you have any questions, I'm happy to take them. Chat.
You can either raise your hands or probably drop it in the chat or Q&A.
Which one should I put?
Okay, Rakesh Ranjan has. Rakesh, you can unmute yourself.
Yeah, thank you. Yeah, it was really a very nice presentation. Thank you very much. One quick thing wanted to understand. I think that can we use in our office laptop like some Anaconda or Mini Conda we need to install in order to learn these things, right?
Right. So yeah, you can get away with Python. But there's this thing called I'll post the link. So there's actually a thing that where you just run it and it'll open a server with a UI, and all you have to do is drop your data set and it'll train it for you. So it's called Axel or Cetal or something. I'll send that as well. But so on your laptop, one, it has to be Windows with a GPU and whatnot. You will be constrained to doing QLoRa because you can't, you won't probably have a lot of RAM to do it. But yeah, it's entirely possible to perform QLoRa fine tuning on your laptops.
Mine is Mac actually.
So the support is coming. This library called MS Swift that has recently started supporting MPS. So, but again, you have to stick with QLoRa on smaller models, but it's like entirely possible. And I'll send the link of the GUI based fine tuning one.
Yeah, and if there is some good video tutorial is already available, means if we want to go in little bit more depth, so please share with us.
Yeah.
Yeah. Thank you.
Thank you, Rakesh. All the resources that we mentioned in the chat, Anil mentioned in the presentation in the talk, We'll be sharing it, as soon as possible by collecting everything, and you'll have everything in your place along with the recording. Uh, we'll wait for a few more questions. Please raise your hand or please drop any questions you might have in the chat.
While we wait for questions, I can show some of the data sets probably, because why not? So yeah, the one I mentioned about context-free grammars, right? That's guidance. So it used to be under Microsoft, but now it's got spun up into its own thing. So let me open constraint generation or something like that. So you can see here that you are constraining a normal language, right? So you can say that you will basically force LLM to say, I like the color, and the LLM now has a choice of only selecting three things, right? It's very hard to sort of get this level of control in doing that. So this is all context-free grammars and whatnot. So that's something. So guidance is mostly for using existing models, but yeah, you can, that's one thing. What else? So this is the GRPO one that I really liked. It was published yesterday, as I mentioned. So this is sort of the data set, right? And I had an example in it as well. So this is the original, Irish journal data set, and then they've used different LLMs to just modernize it so that you have a model you can train on classifications. That's a really cool approach as well. And the one I mentioned here is Z, right? The data set I've mentioned. So they used Claude to generate a bunch of examples, and this is how it works. Let me just close this off. You have the user edited diff, you have the actual input with the constrained region where it can make edits, and then the output of the model itself. So the way they went about it is they first generated 50 or so samples. They fine-tuned a model, they put it into production for their alpha users, internal users, and they've basically collected more data. So they did DPO and data collection in parallel, more or less. So that's how they came up to like 400. So that's another really cool approach. What else can we cover? Yeah, Wikipedia and all this, I guess, this is pretty fairly known as well. So yeah, I wanted to quickly show and shout out to all these people, right? Like it's incredible resources that are all open, and I'm gonna share them as well, along with like this more stuff. But yeah, that.
Any more questions? Anyone from the audience? Cool. I think Anil, in that case, yep. Thank you, Anil, for that wonderful talk. Your deep dive into fine-tuning and distillation of language models, large language models. I'm sure it has offered a fresh perspective on how these models can be optimized to, power non-chat experiences. It's exciting, for me as a non-engineer, engineer at heart, but as a non-engineer who is working in marketing to see how LLMs are evolving beyond conversational use cases. And I'm confident our audience will take away valuable ideas to build more focused, efficient, and enterprise ready AI applications. Before we conclude today's session, I'd like to take a moment to reflect on why events like Grid Dynamics matter, Dynamic Talks matters. At Grid Dynamics, we believe in empowering the tech community by sharing knowledge, fostering innovation, and building connections. Your participation today, whether as an attendee, a speaker, or a collaborator, helps strengthen this ecosystem. For those of you inspired by today's discussion, we invite you to explore how you can be part of our journey. Whether you're a seasoned professional or a curious learner, Grid Dynamics offers opportunities to work on cutting edge projects, grow your skills, and shape the future of technology. Visit our career site to learn more. It's already linked in the resources tab. Please stay tuned for more interesting dynamic talks in the coming months, where we'll continue to explore many transformative topics and host industry leaders. Follow us on LinkedIn to stay updated. We'll love to hear your feedback. It is very important to us. Please take a moment to fill out the feedback form, which will be shared post the webinar. Finally, thank you all of you for joining today. Your engagement makes these conversations meaningful. Until next time, keep innovating, keep learning, and keep pushing boundaries. Thank you. Have a fantastic day, everyone.
Thank you.
Thank you, Anil. Anil, I think there's a question. Just a second. Where will you share the resources? I think this to me. Dishant will share the resources over email. You'll be getting them, to your email ID which you register. Which other events are planned for the future? I'm attending first one of yours. Thank you for this session. Yep. So we have one on 19th, which focuses on this 19th, June 19th, which focuses on the role of SLOs, SLIs, and SLAs for SREs, which is being hosted by Sri Sainath, our DevOps engineer. We'll be covering how do you ensure customer happiness in this particular concept. So please feel free to attend that. You can check it out on our careers page, our LinkedIn page on, our LinkedIn page. So please feel free to register and, join it. I think that's it. Thank you, everyone. Thank you, Anil. Have a fantastic day. Please take care. Good night.